Today's video is about Unit 7 that talks about RC circuits. But to begin with RC circuits, we need to talk about Kirchhoff laws. So we're gonna talk first about current. Kirchhoff law. So this law establishes that all the currents that enter the node must be equal to the ones exiting the node. But in order for you to understand me, this would be the thing that we would call node, and it would be, for instance, node A, because it's easier this way. And we would have current 1 entering the node. We would have current 2 exiting the node, and we would have current 3 exiting as well the node. So what this Kirchhoff law establishes is that I1 must be equal to I2 plus I3, and that's quite easy. The next law we're gonna see is voltage law. Kirchhoff law. In this law, Kirchhoff establishes that the sum of the voltages occurring in the mesh must be equal to 0. I'm gonna draw it so you can see what I'm talking about. We would have a voltage source here, another voltage source here, a resistor, and another resistor here. So this would be R1, R2, R3, B1, B2. So in order to understand this law, you have to know what's a mesh. A mesh is the black thing that I have already colored in black. And the loop would be the trajectory that you would decide either if you go in the direction of the clock or in the opposite way. I always choose the clock's direction, but you can choose it however you want to sum or subtract. So this would be my loop 1. This would be my loop 2. Notice that my arrows are like marking the direction, and this would be my loop 3. All of the loops have to be in the same direction in order to not have different signs. So in that way you couldn't answer your problem. Now that we've established the laws that we're gonna use to solve our circuits, we have to talk about circuits of a mesh. Well, these ones are quite easy since we're just gonna have a resistor, a voltage source, let's draw another voltage source, and another resistor. So this one we would call it R1. This would be B2, this would be B1, and this would be I'm gonna change them, R1 and R2. So basically what Kirchhoff establishes is that you're gonna have to follow this trajectory. And you can see that we only have one trajectory since we just have one mesh. So the voltage, the Kirchhoff voltage law for this mesh would be B1, minus B1 plus R1 I plus R2 I plus B2, and this should be equal to 0. That's how we would solve a circuit of just a mesh. And if we need, we'd also need to talk about circuits of several meshes. And what would be a circuit of several meshes? Just to establish the simplest one, we just draw one of two meshes. So this would be R1, this would be R2, this would be R3. Plus B1 plus minus B2 plus. We always have to follow the voltage drop since that's how the current goes of what I said. So the current would go this way, the voltage drop, and this one would go this way. So the next thing we can do is establish a Kirchhoff current laws for my nodes. I'm gonna say that this one's my node B and that this one is my node A. So Kirchhoff current laws for node A, I would say that for node A, I2, which would be the one passing through the resistor, would be entering node. So it's I2 equals the ones that are exiting. That would be I1 and would be I3. So it would be I1 plus I3. And now let's follow the trajectory of these currents to see what is happening in node B. I'm gonna point how the current is going, so we can see that it would be entering the node, and we can see that I3 would be also entering the node. So it would be I1 plus I3 entering the node equals to I2 that it's exiting I2 that it's exiting the node. So we can see that these two equations are the same. But we cannot solve anything with this since we don't have any of these values, and we have three unknown data, that it's the three currents, and we just have two equations. So we're gonna make use of the voltage laws for the circuit. I'm gonna redraw it so you guys can see how I. So this would be my loop 1, my loop 2, and this would be my loop 3. So for loop 1, I know that, well, I have minus B1, that it's mine, plus R1. I also have to draw the currents, that's something that I forget. Since I know that these ones are going through the same voltage drop, this would be I1. Okay, that's a 1. This would be I2, and this would be I3. So I know that I'm following the same direction of the current, so I would be summing instead of subtracting. So it would be R1 times I1 plus R2 I2, and that would be equal to 0 because that's what voltage Kirchhoff law establishes. For loop number 2, I have it is also entering the positive sign of the voltage, so it would be B2 minus, since it's going in opposite ways, minus R3 equal to 0. And I'm gonna do the last one, that would be R3, and I'm gonna do the external mesh. And I'm gonna start with B2, that would be B2 minus B1 plus R1 minus R3 I. And what you can do now, since we have 3 unknown data and 3 equations, is that you can get them in your calculator or in a software that solves function systems, or you can solve for 2 of them and substitute them in this equation, and you would have the value. For example, let's say I've solved in L1 for I1, that it's I1 would be equal to minus R2 I2 plus B1 over R1. And in loop number 2, I would solve for I3. It would be I3 is equal to minus R2 I2 over R3. I'm forgetting this one. That would be plus B2. So now I have the values of I1 and I3, and I can substitute them in L3, and I would obtain I2 and then just substitute them in these ones, and that would be quite easy to know the values of our currents. We need to talk about how to measure current and how to measure voltage. So ammeters and voltmeters are the ones in charge of measuring both of these values. So it have this is a device that has to be placed in series in order to not affect the current value. It measures current, and this one has to be in parallel in order not to measure it with the circuit, and that's what I talked about in the last video. So active in series, that's it. Now we're gonna talk about RC circuits. RC circuits are the ones that have a capacitor in them. That would be a resistance and a them. And what the capacitor does in the circuit is to establish some balance in the current. So in order to analyze the capacitance in the circuit, we have to analyze the charge of the capacitor and the discharge of it. We would analyze them in 3 period times. One would be when the circuit is open, that would be like this, and we know that the voltage would be equal to 0 since we would have an open circuit and we wouldn't have current flowing through it. Then we would have immediately when it closes that the voltage would be different of 0, and the final analysis would be when it has passed a long enough time. That would be the voltage equals to the voltage source. So the charge is given by where tau is times constant. And the discharge would be given by the same formula, except that it would be minus now I'm gonna do a quick problem in order for you to know what we did. I'm gonna erase this one. I'm gonna invent a problem, and I'm gonna have a voltage source here of 20 volts. I'm gonna have a resistor here, and I'm gonna have another resistor here, and I'm gonna have final resistor here. So this would be of 4 ohms, this would be of 2 ohms, and this other will be of 2 ohms. So I want to know the current that is passing through this resistor, that would be Ix. So I know that I have to do Kirchhoff laws, but what is easier to do is to do a mesh analysis, and I'm gonna teach you how to do it. You just mark would be your loop 1, your mesh 1, and your mesh 2. So what is happening in the loop 1 is that you have minus the voltage source plus what is happening in your 4 ohms resistor times the current that it's flowing through it plus 2, and as you can see you're sharing 2 currents, so it would be I1 minus I2 plus, and that would be equal to 0, and L2 would be 2 ohms, 2 ohms times I2 minus I1 and 2 of I2, and we know that I2 is equal to Ix, so you're just going to get in your calculator and you're gonna solve them, and I'm gonna tell you this one goes the opposite way. So Ix is equal to, wait, we would know that I1 is equal to 4 amperes and that I2 is equal to 2 amperes. So we would know that Ix is equal to minus 2 amperes. And that would be all for this video. Thank you.